In the next couple of videos, what we're going to be putting together is a solution to a potential problem that the RPC framework is going to run up against when deploying to either iOS or the new IL2CPP runtime that Unity is developing. So for the new runtime, if you guys haven't heard, Unity is working on a new .NET runtime that uses the same ahead-of-time compilation strategy that you would use for iOS builds. And I mean, long story short, I highly encourage people to go out, Google IL2CPP. It's IL number 2 CPP. Google that, and then read the blog post from Unity if you haven't already. It's titled "The Future of Scripting in Unity," and that'll give you a good overview of this new runtime. And one of the things about this runtime is, like I said, it's going to impose some of the same limitations as the iOS runtime, or the iOS deployments. And I've been aware of a potential issue with the RPC framework, or an actual issue with the RPC framework for a while now, because of the way some limitations we have when deploying for iOS. But now that I hear that these limitations are going to start applying to more builds as Unity continues to develop IL2CPP and roll it out, I think that we need to now address that issue. And the issue is that the iOS builds and the new runtime make use of ahead-of-time compilation, which means that instead of things being compiled down to IL and ran on top of runtime, things will be compiled down to a native machine code and executed in the context of a very, very thin runtime that won't have all the features of the full runtime. And the feature that we are currently using that we will no longer be able to use in the future is dynamic code. Basically, our Castle dynamic proxy, which is dynamically creating a class at runtime and hooking it up and doing all that fun stuff, well, we're just not going to be able to do that anymore once the IL2CPP runtime rolls out. And we were never able to do it for iOS either. So anything that generates code at runtime is going to be problematic. That being said, the whole concept of automatically generated code is really important to this framework, and will continue to be important, especially when we start talking about our serialization engine that I want to put together. I want to put together a serialization engine that makes use of dynamically generated code. So I don't want to give up the power and flexibility of dynamically generating code, but if we can't do it in the way we're doing it now, we're going to have to come up with a new solution. And the solution I came up with was generating code during the build process of when we build out our solution, having a trigger happen that goes out and generates code and then, well, shoves it into a file that's included by the project, and then the C# compiler comes along, reads in the generated code, and compiles it along with the assembly. So that's basically what I'm going to be showing you guys how to do. It's pretty straightforward technique. I've gone through a lot of different potential solutions to this problem, and the solution I'm going to show you guys is I think the most robust way that I came up with. I really wanted to take advantage of the Unity 5's asset pipeline, because basically Unity 5 is Pro. All the features from Pro are now available for free, and now we can take advantage of the build pipeline and all that fun stuff. However, after a couple days of wrestling with Unity, trying to use the new Unity asset pipeline to generate the code, I simply wasn't able to. There was a catch-22 where if I changed one of the interfaces that the generated code would implement, I wouldn't get a hook to regenerate that code, and I would get an error, and it wouldn't let me play, it wouldn't trigger my code, and it was just this big mess, and it wasn't very fun. So I came up with a different solution. The basic rundown is, you see our projects here, such as our client and our server. I want to hook into a pre-build event and write to a file that's included by the project. And like I said before, this is going to be a pretty robust solution. And it's also going to be an appropriate solution, for example, for our serializer that we'll be putting together at some point. Okay, so in addition, I didn't want to just... I came up with this solution, but part of the problem is I need to execute a tool, another executable, like a console application, to actually perform the dynamic code generation, or not dynamic code, but static code generation. I needed like another console program to do that. I couldn't do the code generation in the same process as the build, as MS Build itself. I had to do it in a different process, or I would have had to do a bunch of app domain juggling. And the reason is I have to load in the buzzmmo.base DLL into memory in order to figure out which one of these, interfaces need to be implemented. And so to do that, I needed to separate it out into a different process or juggle app domains, and I didn't want to do that. So what we're going to do is we're going to introduce another project into the solution, and it's going to be a command line tool. And we're going to use it for different command line tasks throughout the development of the series. However, I did want to make it a little bit more general purpose, and as a result, I came up with a command line argument parser system. And what I want to do is I want to implement that command line parser or command line interface system and just have it to be a really bare bones parser and executor for text-based commands that we can build on in the future. And we'll reuse this command line interface for something like, how like you can type in chat commands, and if you're an admin, you could type in, your own commands and all that stuff. So I wanted to also just have that as well, just the skeleton of it put together. And words and words and words and stuff. So basically, the basic rundown of what we're going to be doing in the next couple of videos is the end goal is that we have code statically compiled that implements these interfaces and is added into the BuzzMMO client and BuzzMMO server assemblies during compile time. Then I want to also build a command line tool that we can extend in the future to do other command line tasks, and I also want to abstract out a command line interface class that we can reuse for a variety of different circumstances. So that's what we're going to be doing, and should be lots of fun. So I guess I'll just go ahead and end the video here, and in the next video what we'll do is we'll start off by stubbing out our command line interface class. So our command line parser, we can write that and we can test it using unit tests before we even start worrying about creating the additional tool or creating the code that generates the code. So yeah, I guess we'll see you guys in the next video.